Alright guys, here we go. So, number 11 on your math workshop talked about volume. So volume is length times width times height. And then it told you that the volume of the prism was 6x cubed plus 11x squared plus 4x. And then it told you height was x. Alright, and then in part A, it asked you to find the length and the width. So that means you have to get rid of this x. Well, you're multiplying by x. The opposite is to divide by x. Alright, so those x's cancel. And on the other side, the left side, when you're dividing the bases, you subtract the exponents. So that leaves you with 6x squared plus 11x plus 4 is equal to length times width. Well, you've got to make this guy be two things multiplied together. And to do that, you factor. So you take this 6 and you multiply it by the 4. Then you take factors of 24 that add or subtract to be 11. That's 8 and 3. Then you have to divide by that number you slid to the back. Then we're going to reduce. 8 and 6 do not divide, but they reduce by 2. So that leaves me with 4 over 3. 3 over 6 reduces by 3 to give me 1 over 2. Not 2, 1 over 2. Alright, we don't ever leave our answers like that. Then we do bottoms up. The bottom number comes to the front, and you get 3x plus 4 and 2x plus 1, which means your length is 3x plus 4, and your width is 2x plus 1. And you have now successfully found the length and the width. And we did not do part B due to time. And we are going to review our ACT problems tomorrow. So what we did from here is we went to page 5 on your 8.2 notes. Alright, so what you need to do first is you need to factor the denominators to see if they're already similar. So this guy factors as 3, x minus 5. And this guy factors as 6. X minus 5. Well, they're already very similar. They already both have x minus 5. So you need to find the least common multiple, the smallest number that 3 and 6 go into, and that is 6. I did not ask you what went into them. I said, what does 3 and 6 go into? And that is 6. So to make 3 become 6, you multiply it by 2. And it's perfectly legal to multiply by 2 as long as you do it to the top. That way they will reduce and give you the same thing you started with. And now we're going to distribute that 2 and give us 2x plus 20. And this negative sign goes to everything behind it. So if you want to imagine that there's parentheses right there, that negative is to both of those. So it's not only minus 3x, it's minus 15. Instead I give you 6 and x minus 5. Alright, so then we combine like terms. We have 2x minus 3x is negative x. We have 20 minus 15, and that's 5 over 6 x minus 5. Alright, then you have a GCF on the top of negative 1. So if you take out that negative 1, all it does is changes the signs. And remember last week, I told you that every once in a while when you're adding and subtracting, something will reduce. Once you have multiplication, you're multiplying that with negative 1 and 6, then you can reduce those binomials and get negative 1 over 6. Alright, then we went to number 4 after that. So the same thing, we're going to see if the bottom will factor. And this guy factors as x plus 6 and x plus 3. Showing me that they're already very similar. The only thing that this guy needs is an x plus 3. And you can just put an x plus 3 there. It's okay. As long as you do the same exact thing to the top That way you could reduce them and get back the original problem you had. All right, so you have 4x plus 5 times x plus 3 on the top. And you have x plus 6, x plus 3 on the bottom. Now you cannot cancel out the x plus 3's because you are adding this 5 right here. So you have to distribute that 5 first, which gives you 4x plus 5x plus 15 over x plus 6, x plus 3. Then you combine like terms. 4 plus 5 is 9. Then if you can see that the top factors but nothing reduces, you could leave it like this. That's okay. Or you could factor out a 3 from the top, because that has a GCF of 3. That means 3 is the smallest number that divides into 9 and 15. And then you can see that nothing cancels. So you can start, either one of those is correct. All right, then number 5, same thing. You've got to factor this guy as y minus 9 and y minus 3. And then you can see they already have a y minus 3 in common. The only thing that they're missing is this guy is missing a y minus 9. And it's okay to just stick a y minus 9 there, as long as if you did it to the bottom, you got to do the same exact thing to the top, so that they will cancel and give you the same problem you started with. All right, so on the top, distribute that 8. That gives you 8y minus 72. Get a plus sign, so none of those signs change with a plus sign. And your denominator is y minus 9, y minus 3. Or y minus 3, y minus 9. It doesn't matter the order, as long as the 3 stays negative and the 9 stays negative. Combine like terms. 8 plus 2 is 10. Negative 72 minus 5 is negative 77. Nothing factors, so you're done. All right, number 6, 3x minus 6 factors with a GCF of 3. X squared minus 4 is the difference of 2 squares, leaving you with x plus 2x minus 2. All right, you notice they already have an x plus 2 in common. All right, well, this guy has a 3 on the left. So in order to make the right side have a 3, you've got to multiply the top by 3 as well. You've got to make it equal. You've got to make it balanced out to what you had to begin with. All right, now they both got a 3. They both got an x plus 2. But now this guy has an x minus 2. So I need to make this guy have an x minus 2 by multiplying on the top and the bottom. And if you used a binomial, you have to use parentheses around your binomials. All right, so now on the top, let's distribute that 4. That leaves us with 4x minus 8. And now we have a subtract that we are distributing along with that 3. That gives me negative 3x minus 3. And on the bottom, I have 3x plus 2x minus 2. All right, combine like terms. 4x minus 3x is x. Negative 8 minus 3 is negative 11. Nothing cancels out. And that would be your answer. Or you could go ahead and put that back into the difference of 2 squares if you wanted to. Either one is fine. All right, we did one more problem on the back. Go ahead and flip over to the back of that. And you see these are kind of different. All right, if you will flip back to page 1 and look at numbers 11 and 12, you will see that these are very, very similar. I think it was something like that. I'm doing it from memory. I think that was the problem. All right, so the difference here is that this is already one huge fraction. And if you look here at my numerator, it's not one huge fraction. It's a number plus a fraction. So they're not completely the same. So we need to make, number 1, one big fraction in the numerator and in the denominator. All right, so come over on the side. Well, to make 1 become a fraction in the first place, you put him over 1. And now that we've gone through 8.2, we know in order to add fractions, they have to have the same denominator. In this case, that would be 1x, or just x. And I can't actually add those together, so I'm just going to smush them together like that. And now I can change that numerator to x plus 1 over x. All right, let's take our denominator. We have 1 minus x over y. Well, to make 1 a fraction in the first place, you put it over 1. They have to have the same denominator, so you're going to multiply by y on the top and bottom. So it leaves you with y over y minus x over y. Now they have the same denominator. You can't actually subtract x and y, so you're just going to leave it like that. Just going to smush them together. All right. Now, you do not want to have 3 fractions all together. You want to keep the first fraction. You want to change this division. Let me change this in a different color. You want to change this division bar to multiplication, and then you want to switch this bottom fraction. Alright, so that means we're going to keep the x plus 1 over x. We're going to change division and multiplication, and we're going to flip that bottom fraction on his head. We're going to flip him around. Alright, so these x's will not cancel because you're adding that 1. These y's will not cancel because you're subtracting an x. So you've got to be very, very careful. Nothing here will actually cancel. Nothing is being multiplied that cancels out that are the same. So all you do is smush them together. You take that monomial of y and put him in the front, then put your binomial on the back, and the same thing on the bottom. Your monomial comes first, and then your binomial. Your monomials of x and y do not cancel, and your binomials of x plus 1 and y minus x do not cancel. So that's your answer. All right, and then all we did after that was a checkpoint for 8.1, and that was it for the rest of the class period. We have a math workshop test on Friday. I believe that is the 2nd of March. It's this Friday. And then next week, probably on Tuesday or Wednesday, we'll be looking at a Chapter 8 test, and that will be it for 3rd quarter. That will be it for 3rd quarter, okay? All right, let me know if you have any questions and come see me.